three questions basically. Basically, the first question. All these questions are variants of the tutorial questions. I use ChatGPT to come up with a different type, with the different questions, but it's a similar type of questions. The how you solve it is basically similar, but the scenario is different. So when you go back to your tutorial questions, you can try to do it on your own. And of course, at the same time, you can also get the solution manual to help you with the solutions. Okay, so for today, we're going to discuss three questions, yeah, for this first tutorial. So you can see, we can see here. And without further ado, let's go with the first one. Yeah, with the first one. Right. Basically, this tutorial question should cover the second chapter that we have just completed. I hope you guys already have managed to see the third part, yeah, of the lecture video online. Starting next week, we're going to go into chapter 3 already. Right, going back to this first question. Small office space typically accommodates 15 employees to be cooled using portable aircon with a 3 kilowatt cooling capacity. Right. Average office worker estimated to generate heat at 450. 450. I can see it. 450 kilojoule per hour. Has 8 computer workstations. Each consume 200 watt of power. So you also have 6 LED fixtures, each 50 watt. The heat gain to the walls, windows, and doors is calculated to be 8,000 kilojoule per hour. So if the temperature is to be maintained at constant 23 degrees C, how many portable air conditioning units are to be needed? So if you can notice here, it's basically more or less similar to the tutorial question, just that it's for a different scenario. So the first order of the day is that to solve this particular question is you need to calculate the heat load. Yeah, we start by calculating the heat load, and then after that, after you get the heat load calculation, and then we can see what is the capacity for a single air conditioning unit, and then from there we can determine the number of air conditioning unit. Okay, so for the heat load calculation, basically there are three types of heat load. Yeah? The first one is the employees. Okay, for the employees, you have 15, right? So you have 15 employees. So each they generate for this one using portable connect 3 watt. Okay, so they have 15, and each of them actually generate 450 kilojoule per hour. So you should amounting to 6,750 kilojoule per hour. The next part will be the computers. You have 8 computers. So you have 8. Okay, now for these computers, actually you have 200 watt each. But notice that you have the unit. Okay, notice the unit. We prefer that for homogeneity, we prefer that we have a singular unit. So if you want to convert this into kilojoule per hour, you have to times 3.6 kilojoule per hour per watt, which equals to 5,760 kilowatt hour. Okay, kilojoule per hour. Sorry, this one should be kilojoule. Where's my eraser? This one should be kilojoule. Kilojoule per hour. So notice that now our unit is homogeneous, have similar unit. So how you get this? Basically, 1 watt is equals to 1 joule per second. But now we need to convert to kilojoule per hour. So you know lah, right? Joule per second, you convert to per hour, you divide by 60 times 60. And then you can get 3.6 kilojoule per hour per watt for every watt. So that's why you have 8 times 200 watt. Next, you have also the LED. So for our LED fixtures, we have 6. Similarly, each is 50 watt times also 3.6 kilojoule per hour per watt, which is equals to 1,080 kilojoule per hour. Okay, you need to make sure the unit is the same, for each of them. You need to make sure that the unit is the same. So for the internal cooling load, internal load, you total up all these three, you should get the value at 13,590 kilojoule per hour. Okay, that is for internal load only. But then again, if you look into the question, there are also heat gain through the walls, windows, doors, and it is calculated at heat gain. calculated at 8,000, right? This amount, 8,000 kilojoule per hour. So once you have that, means that the total heat load will be just simply total up lah. So which you should get 21,950 kilojoule hour, right? So this is your total cooling load. So for if each aircon unit above the cooling capacity is 3 kilowatt, so how you're going to calculate the number of air conditioning unit? So first of all, right, you need to first convert, because from the question here it's given it's in kilowatt, so you need to convert them to kilojoule per hour. So similarly, so you have 3 kilowatt, one unit times 3 kilowatt hour times 3,600 kilojoule, sorry, kilojoule per hour. So you're going to have 10,800 kilojoule per hour. Okay, right? So this is the capacity for a single unit. So the number of units, so you just simply divide by these two values lah. Yeah. So 21,950 kilojoule per hour divided by 10,800 kilojoule per hour. You should get the amount as 1.999 unit. But of course, you cannot get, or you cannot use 1.9 unit, right? You either use 1 unit or 2 unit or 3 units. So in this case, we simply use 2 units lah. 2 units of air conditioning unit. Okay, so quite straightforward lah in this case. Okay, so in this case, you just simply calculate the internal load and then calculate the heat gain, and then after that you divide by the number of aircon unit, right? That should conclude for question number 1. Okay, that one. So later you can review lah. Right. Next, we go to question number 2. This one. A solar powered irrigation pump advertised to lift water from an underground well to an elevated storage tank on the farm. So the pump reportedly used 1.5 kilowatt of electrical power from solar panels and can pump water from a depth of 20 meter below ground level to a tank with its base 15 meter above ground level at a rate of 40 liter per second. So the question is, determine if this claim is reasonable or not. So you have to determine. So of course, you have to calculate what is the actual power required to pump water 20 meter below ground and 15 meter above ground level. So with that, first, of course, if you want to calculate this, you use the formula work equals to mgh, right? Of course, this formula will give you joule per second lah. The default unit is joule per second. But here, they claim in kilowatt. So for power, it's in terms of time or second. So for power, W dot equals to M dot GH. Hopefully you can see the dot over there, right? So we know gravity is a constant value lah, so no issue there. For the H, straightforward, you simply add 20 meter plus 15 meter. So this one you get 35 meter. For the mass flow rate, how to calculate for the mass flow rate? So for the mass flow rate, is simply as you convert, because here it's given 40 liter per second. So you just simply convert them into mass flow rate. This is the volume flow rate, 40 liter per second. So you convert them to mass flow rate. You just simply times the mass flow rate. To calculate for mass flow rate, you simply volume flow rate times by the density. Okay, so you have 40 liter per second. Your 1,000 kilogram per meter cube, or if you express them in term of liter, because the volume flow rate is expressed in term of liter, right? So basically, for the density of water is equals to 1 kilogram per liter. make sure that your unit is right. Make sure that you have the right unit. So in this case, this one will cancel out. You're going to have 40 kilogram per second. So this is basically your mass flow rate. Now, having this, we can simply use this formula. Yeah, we just simply use that formula to calculate for the minimum power required to transport or to pump water for about 35 meter. So solving for that, you just put in the value times by 9.81 times by the height is 35. Solving for that, the minimum power required would be 13,734. This one is in terms of watt or in terms of kilowatt lah. Okay. Now, we can see here that this is the minimum power required, whereas this statement claims that they can use 1.5 kilowatt of water. So what is the conclusion here? All right. So what we can say is that the claim is not reasonable. This guy is trying to make our money gone. Dia mau tipu ni. This guy is cheating the salesman. Okay. So basically, this kind of question is something that the type of question that you have to make. You have to make judgment whether it's suitable or not. So expect to come out to stumble upon this kind of questions lah in your test or in your exam. Okay. Right. So with that, that is for question number 2. Next, we go for question number 3. One, it's a very short one, actually. We did not actually discuss a lot of questions lah. All right. So question number 3. For some reason, when I write the writing is not that clear. I'm not sure why, but maybe we're going to use a different software next time, which can have better output. All right. For the third question, 50 kilowatt electrical input industrial refrigeration compressor with an efficiency of 88%, replaced by new energy efficient model rated at 50 kilowatt, efficiency 93%. So calculate the decrease in heat release to the surrounding area due to the improved efficiency when both compressors are operating at full capacity. So they request us to calculate what is the reduction in heat gain. When you talk about efficiency 88%, means that out of the 50 kilowatt electrical input, only 88% of the work output coming out from the compressor. Okay, the rest, what happened? Remember the first law of thermodynamics, you can convert energy from one form to another. So if only 88% is converted to work, what happened to the 12%? Okay, so in this case, it is assumed that it is converted into heat. Of course, in actual situation, maybe there are losses to friction. There are other type of losses lah. Okay. Right. So here, we analyze the old compressor first to calculate how much heat is being generated as compared to the new compressor, how much heat is generated, and then so from there we can identify the decrease in heat release. Okay. So for the old compressor, the electrical input is 50 kilowatt, right? So if the efficiency is 88%, so the actual output, of course, will be 50 times 0.88, which is equivalent to 44 kilowatt. All right. So means that if only useful work goes out only 44 kilowatt, the heat increase because of the inefficiency will be 6 kilowatt. Okay, so this one is for the old compressor. For the new compressor, right? So we have the input is basically the same, but the efficiency for the new compressor is 93%, right? So it's 0.93. So you have 50 times 0.93, and you should get 46.5 kilowatt. So I mean the heat increase. The heat increase is only 2.5 kilowatt. So the decrease in heat release to the surrounding is what? So you just simply 6 minus 2.5, you're going to get 3.5 kilowatt heat decrease. Yeah, heat decrease. Okay. So for tutorial 1, this is the questions lah that I distributed already in the title. So from here, from this tutorial question that we have discussed, hopefully it helps you to answer the tutorial questions. Remember, for the tutorial questions, you need to write in a piece of paper and then scan to PDF and then submit. If you start, of course, you can find them also in the solution manual. Okay. So for our first tutorial today, it's a very short one. We just discussed these 3 questions lah. Okay. So I think with that, we have discussed the tutorial questions for today.